Yes, so I am an architect by training, I guess. I have recently stepped into an environmental consulting role with Atelier 10. So I guess there's been a bit of a journey in that. When I moved to Melbourne a couple of years ago, I joined JCB Architects, and I believe you've interviewed a couple of the guys from there on this, well, several different projects. One of the projects which sort of set my trajectory as an architect off in a slightly different direction to what I, always thought would be a very linear process, was the Monash Gillies Hall project. So we can talk a little bit more about it in a moment, but essentially that introduced me to the sort of the performance side of architecture and how we as architects can really design to decrease our impact on the environment through buildings. I kind of knew that existed before, through mass timber and, sequestering carbon, etc. But the operational side was always a bit of a mystery, a finger to the wind, let's hope for the best with cross ventilation. Now, the passive house concept obviously flips that on its head. It gives you ultimate control over the interior environment, and I was completely taken by this concept. So that led me to, I worked on the Gillies Hall project as the core team from concept to tender stage, and then I moved across to ARKit, where I explored some prefab opportunities to reach the passive house standard in resi and education buildings. So it's been a bit of a journey through mainstream architecture, construction, and then now into a consulting role as a sustainability consultant, which I never thought I would end up in, but it's all kind of headed that way.
Yeah. Oh, it's a fantastic mix: sustainability, prefabrication, and passive house. So how do you see prefabrication influencing construction going forward? And as we move through the conversation, we can touch on passive house and sustainability also.
I think there's a huge opportunity to increase the quality of construction through prefab. The off-site methodology allows you to really control tolerances. It allows you to control, the material and how it's affected by weather, or in this case, not affected by weather. And it allows you to essentially install things like windows into panels before you get them to site. It takes the guesswork out on site, essentially. And, there's a lot of development that it still needs to happen in the Australian prefab world. Not every firm has access to the machinery required for, advanced, design for manufacturing and, the more automotive systems. But I think there's a lot of work being done in that space of, traditional building methodologies happening off-site, and just the opportunities that small step has given builders has been pretty fundamental. Accelerated construction timeframes, being able to scale buildings as well, and repeat details. So you build in these sort of efficiencies. Again, there's probably so much opportunity to progress that here in Australia, and I think there's been a recent launch of by the Advanced Manufacturing Growth Centre. There's been a little announcement about an innovation hub that they're setting up for prefab building. So that's a space to watch. Hopefully that will support the industry really break through some of the barriers that it currently has.
Absolutely. And you mentioned with prefabrication, you can improve the construction tolerances and manage quality to a high degree. How does this enable passive house design and achieving this form of construction method?
So the tolerances are quite important in passive house. So one of the scariest things for builders is the air tightness factor. You're targeting a 0.6 air change rate, which is, God knows how many times better than what we have at the moment. But the average house is built to about 10 air changes per hour. So it's a substantially tighter building. And to to get to that level of air tightness, you really do need to pay attention to the way things are obviously sealed. Windows are installed, how walls are joined to roof elements, how the structure is working, what materials you use as well, and the sequence that you build it in. So the prefab aspect and the offsite construction opportunities there allow you to essentially, it puts more pressure on the design side. So you really have to figure things out when you're at the drawing board stage. And I think, without leaving it till it's on site, like a lot of details are still sort of sorted out, on site when problems occur. Really having it sorted before it even leaves the factory is a big head start. And as I said before, being able to pre-install things like windows and those more tricky elements to get right it just makes life easier. It gives you a chance to do it before you're in the weather, before you're always under a tight construction time frame, but it just gives you that leeway to get it right before it heads off with sub-trades poking holes in it, whatnot.
Yeah. I'm jumping around a little bit. So maybe it's worth exploring what's the upside of doing passive house design also, and just to see, are most buildings going to achieve passive house, and do you think it's something that should be legislated to improve the overall build quality in Australia?
Look, I'm of course it should be legislated, but we have a little way to get there. So the first part of your question, sorry, what was the first part of your question?
Yeah, I kind of pumped a whole bunch in the same question. What's the upside of passive house?
The upside of passive house would be, well, there's several. There's obviously an energy efficiency, so operational cost savings. So for the owner operator, that is a big plus. You've got a health benefit, so it you can control temperature, you can control moisture, or like humidity. You can control, I guess, the thermal envelope, so that you don't get cold spots or thermal bridges, which can cause mold and damp and things even in places that you can't see, such as inside your walls, affecting your insulation and plasterboard. So there's a big health benefit just to improve the indoor air quality and comfort, and the consistency of temperature and the resiliency to withstand heat waves and cold snaps and all of that. So for say aged care, for schools, for any kind of building with more vulnerable people, it's sort of imperative to start thinking about those things. And then there's of course also the fact that there's less emissions being produced from the operation of your building. So if you're using less energy, you're using less emissions. There's obviously a big conversation about embodied carbon as well, and I think that's where timber comes into it. But yeah, there's many different benefits. Acoustic quality, if you're in an inner city area. Essentially, it builds on from passive solar strategies as well. So you're still making the most of the energy from the sun. You're making the most of orientation and cross ventilation. Funnily enough, even though it's an airtight building, I guess it's just that next advancement from what we've been doing traditionally for centuries.
And you touched on operational energy. What with this energy efficient building, how much are we reducing the operating carbon as just a very high level kind of rule of thumb number?
Well, we've been doing a few studies at Atelier 10 comparing that Hearst standards with the passive house standards. We've run the buildings through the same software and we've given them the same, I guess, envelope composition and assumptions. So that it's apples for apples. We've seen it's quite interesting. From a 6-star building, which is code minimum, we've seen it's a 70% reduction in energy to run that building for passive house standard.
Unbelievable.
Yeah. And I mean, like, that's in a fairly mild climate compared to Europe. I mean, they're seeing figures over 90%, but I mean, for Melbourne, that doesn't get quite as cold as Germany. Or, I think we can start leveraging the ability to reduce the amount of cooling in our buildings.
Definitely. And then, that much reduction in the energy required to power the building, I'd imagine that relates with quite a direct cost saving. So even if it does cost a little bit upfront, you'd get the payback pretty quickly with Passivhaus.
Yeah, well, the German standard, which is the Passivhaus Institute developed, they literally packaged up a bunch of building physics principles so that architects and builders could take them and actually implement them. The building physics principles aren't owned by anyone, but the Passivhaus standard has obviously become that quality benchmark. So they actually have an economics tool in their Passivhaus planning package where you can start to look at the payback. I guess it's always been designed to be paid back over the lifetime of your mortgage. So, that doesn't sound very appealing to the Australian market where we like to flip buildings. But having said that, if you're going to be reducing your energy costs, and look, at some point you will pay it off. And this taps into, the price or the cost of this upfront. At the moment, it's not regulated and it's not mainstream. So there are a lot of builders that are picking this up and running with it and never looking back, and committing only to Passivhaus buildings. But I'd say the majority of builders aren't as familiar with it. So obviously they're going to potentially price a building with a bit of inbuilt risk mitigation. So a little bit of extra cost on there just in case they don't meet the airtightness requirement first go and they have to redo things. Which, again, after you design and build one Passivhaus building, the amount of learnings that you go through, you'll be able to integrate those efficiencies into the next one. And what we've seen across Vancouver and across the big UK, basically anywhere where they've started to really increase the amount of buildings that are built to this standard, they've seen this sort of learning curve plateau, and the cost will go with that. Obviously as well, the components such as windows and doors and membranes, when they become more mainstream and there's more competition on the market, that the price of the materials of the building will come down too. So I guess we're at the beginning of that curve, but we'll see them drop. They've already started to drop. Windows, for example.
Yeah. So as the cost curves improve, then it's the case is just going to increase as we go forward. You mentioned how timber, for Monash, you use CLT for that project, and prefabrication helped a lot. How else can timber help in terms of energy efficiency, thinking about the thermal properties as well?
Well, it's a lot better than using steel and concrete. It's got a much lower thermal conductivity. So it's quite interesting if you put a steel stud with insulation bats between it into a thermal model, and you look at the overall performance of that wall. In many cases, you may as well not put any insulation in that wall at all, because of the thermal bridging happening through the steel studs. Now, if you use timber, you can actually improve the thermal performance of that whole, wall composition. So it makes building to the Passivhaus standard much, much easier. And that's with timber studs, for example. Now with the CLT, you often still need to insulate on the outside of it, but it reduces the amount of insulation, I'd say. And if you've got any connections, such as the Gillies Hall, there were a lot of the shading fins had to be connected back to the building. It just made that a lot easier. There was less sort of, fancy thermal bridging, mitigation connection pieces that needed to be used. The timber itself sort of absorbed some of that, the issue there. So, yeah, I'd say it goes hand in hand, and it also looks at the embodied carbon, which we shouldn't forget about when we're designing buildings.
Yeah, that's a good point on the embodied carbon. Do you think as we go forward, as our buildings become more energy efficient, it's something I've noticed a lot. There's a lot of companies talking, or a lot of buildings talking about carbon neutral this, and pledges to go carbon neutral. But a lot of the time, embodied carbon isn't included in that conversation whatsoever. And sometimes I feel like, the planet doesn't discriminate between or doesn't really care where the emissions are coming from. Do you think that that embodied carbon should be included in the definition going forward?
Definitely. I think more and more people or companies are looking at that. So the life cycle assessment tools that are out there, I think it is quite dangerous to say, we've gone carbon neutral with this building, if you haven't addressed all of those things. I think there's a little bit of greenwash happening. If you dig into the definition of carbon neutral, it often means that they've just bought offsets somewhere. They've clad the building in a little bit of solar PV, and then they've offset the rest, and they haven't addressed the envelope, they haven't addressed the embodied carbon, and they've just hoped that someone somewhere is planting some trees for them. I just think that's the wrong way to go about this. We need to address the efficiency of the building. Obviously, that includes the materials it's made from, and then we should think about renewables, and only then should we offset that remaining bit to get to carbon neutrality. That should be the definition of carbon neutral. Unfortunately, that has been hijacked a little bit.
Yeah, I'm sure it'll go in the right direction going forward. Now, I understand you got a scholarship, or the Byron Hadley traveling scholarship, where you were able to travel all around the world and look at the built environment and the way different cities are looking at decarbonising. What were your thoughts on, or what did you learn from that trip, and you could bring back to Australia, and what we can learn here from you in that trip?
Oh, where do I even start? It feels like a distant memory.
Well, what cities did you go to?
Yeah, I went to, I chose Vancouver, New York, Brussels, and then I also added Wellington and Heidelberg in there as well for 2 conferences. But the 3 case studies that I looked at were Vancouver, New York, and Brussels. And I chose them because they're at different points of this sort of journey that they're on for, reducing the carbon footprint of their cities. Starting with Brussels, they actually, within 7 years, overhauled their complete building standard to be on par with the Passivhaus standard. There are so many ways that they managed to do, strategies that they deployed to get there, all of which I think are valuable lessons that we could, look at employing here. So they're sort of at the leading edge. Then you've got places like Vancouver who are incentivizing Passivhaus, or, they're looking at both operational and embodied carbon in their building policies, and they're incentivizing the industry to adopt it. So it's not mandatory, but it's highly incentivized. So you would get, for example, 5% extra floor area if you committed to Passivhaus as a developer, and that is big dollar signs. So that's working quite nicely. There's also a lot of other sort of relaxations of building policies as well, just as an incentive and a way to reduce barriers and red tape to actually pushing above building code. And as a province, they've actually got the energy step code, which is a way of backcasting from a target of carbon neutrality. I forget which date it is, 2040 or something, and then backcasting to the current date and saying, okay, how much do we need to crank that that dial every 3 years to get there. And I think that's a really smart approach. And at the moment in Australia, we have this sort of, we'll just see how it goes, incremental rise in building standards, which we have no idea if we'll get there or not. So it's quite interesting. And
that's
then, of course,
yeah.
And then we've got New York, which, you look at the volume of building there, it's just insane. There's more building than sky. And they're looking at retrofitting their entire building stock in Manhattan, which is Well, yeah, the standard, again, I think they're incorporating a step code change, but essentially they'll eventually get to the end of fit standard, which is the retrofit version of the Passivhaus standard. So it's slightly relaxed in air tightness and a few other criteria, but essentially it's pretty good. And they're using disincentives to get there. So they're fining building owners for every for not meeting their carbon reduction targets. So it's building by building based on they've had a record of emissions. I think it was recorded. How many years they've had that in place, I can't quote, but they have a backlog of building emissions, so that they basically create a little plan for each building.
And retrofitting, what kind of works would they do? Like what's the lowest hanging fruit for retrofitting wise to get better, energy efficiency?
That's a really good question. And we've been working with a few of our clients to figure out what the most effective, what the most simple aspects of a building you should look at first in order to improve efficiency. And look, we're looking at new buildings, but the same would apply to retrofitting. It often comes down to windows. Windows are a big one. It comes down to increasing the air tightness. So that's, energy leaking in and out of your building. And if that's not always possible, if it means, substantial deep retrofit, making sure that the insulation is installed properly and that there's no gaps. There's a few other steps as well. Windows, air tightness, trying to mitigate as many thermal bridges as possible. So either, putting flanking insulation down on your slab, those big ticket thermal bridges, like the repeating ones around the edge of your building. And then also a big one is ventilation. So, in Australia, we rely on opening a window to get fresh air, and we rely on an extractor fan in the bathroom to extract moisture. Now, we lose a lot of energy through those systems, and we can't always rely on people opening a window when it's really cold outside or really hot. So the air quality inside is also affected. So in order to address that, the Passivhaus standard has a heat recovery ventilation system, which is a constant trickle of fresh air into the building, which is passed through a system which transfers the energy from the outgoing air onto the incoming air. So you get this, almost preconditioned temperature. So you're not losing any. Well, you significantly increase the energy efficiency of your ventilation. So we've seen that actually has a huge impact on the energy efficiency of a building.
Yeah, it's so exciting to see, because it is very important that we try and upgrade the existing building stock. And there's a few buildings, like recently 55 South Hank Boulevard, that you might come across, and building on top of existing buildings as well. Because in the past, rather than just knock down and rebuild something, if you're building on top, from an embodied carbon point of view, it's making a very big difference.
Yeah, definitely. We need to look at the buildings we already have. There is so much opportunity to upgrade them. Even with just one of those steps that I said. I think demolishing a building is a huge tragedy. We often do it because it's more cost effective, which is just crazy. We definitely need to start doing what Europe has been doing for many years and just deal with the existing building stock. Yeah.
Oh, thanks so much, Kate. If people want to find out more about yourself, where should they go? You could you could look at the Australian Passivhaus website. So that's passivhausaustralia.com. .org.
you could look at my Hadley report and get an insight into what other cities are doing, and that's on the Architecture Registration Board website. If you just type in Hadley, all of the reports are up there. It's probably the only places.
Yeah, that's fantastic. Okay, well, thanks so much for coming on the podcast.
Thank you so much for having me. It's been great.